Imagine this, a giant asteroid hurtling towards Earth, threatening to wipe out all life as we know it. Sounds like a scene from a sci-fi movie, right? But what if it isn't just fiction? It's easy to dismiss the idea of a catastrophic asteroid impact as a Hollywood invention. We've seen it dramatized time and again in the movies, and it's become something of a cliché. But the reality is, the threat is real, and it's one that scientists take very seriously. This isn't just about the prospect of an asteroid hitting Earth tomorrow, next month, or even next year. It's about understanding that our planet exists in a cosmic shooting gallery, and it's only a matter of time before our number comes up. Think about this for a moment. About 65 million years ago, a massive asteroid, roughly 6 miles wide, struck what is now the Yucatan Peninsula in Mexico. The impact was so powerful that it triggered a series of catastrophic events leading to the extinction of the dinosaurs and wiping out nearly 75% of all species on Earth. Fast forward to the 20th century, and we have the Tunguska event in Siberia, Russia, in 1908. An asteroid exploded in the atmosphere with a force estimated to be about 1,000 times more powerful than the atomic bomb dropped on Hiroshima. It flattened over 800 square miles of forest, and had it occurred over a populated area, the loss of life could have been unimaginable. These events serve as stark reminders of the destructive power of asteroids. They underscore the fact that the threat of an asteroid impact isn't just the stuff of Hollywood fiction, it's a genuine concern for scientists around the world. So, given this threat, what are we doing to prevent a potential asteroid Armageddon? As we delve into this question, we'll explore the fascinating and sometimes terrifying world of asteroid detection, mitigation, and defense. So buckle up as we embark on this cosmic journey. The first step towards confronting any threat is to know it's coming. The same applies for asteroids. To stand a fighting chance against these celestial projectiles, we need to spot them well before they pose an imminent threat. Fortunately, our technological prowess has given us the tools to do just that. Our early warning systems have come a long way since the establishment of NASA's Near-Earth Object Observations Program, or NEO observations for short. This was our first dedicated effort to catalog and track asteroids and comets that could potentially pose a threat to Earth. It was a significant step forward, but just the beginning of our asteroid detection journey. As technology advanced, so did our ability to spot these hazardous objects. The PanSTARRS project, short for Panoramic Survey Telescope and Rapid Response System, is a prime example of this. This system uses an array of telescopes and cutting-edge imaging technology to scan the sky for near-Earth objects, or NEOs. It's like a watchtower that never sleeps, constantly scanning the cosmos for any signs of danger. But our vigilance doesn't stop there. We're always looking for ways to improve our asteroid detection capabilities. This is where the upcoming NEO Surveyor mission comes into play. This mission aims to launch an infrared telescope into space to find, track, and characterize potentially hazardous asteroids. By observing in infrared, we can spot asteroids that might otherwise be missed by ground-based telescopes. With these systems in place, we have a much better chance of spotting an asteroid before it becomes a threat. But spotting it is just the first step. Once we've detected a potentially hazardous asteroid, we need to determine its trajectory, size, and composition. These factors will greatly influence our strategy for dealing with the asteroid. Detecting an asteroid early gives us time, and time is the most crucial factor when it comes to deflecting a hazardous asteroid. The more time we have, the more options we have at our disposal. And in a race against time, every second counts. Alright, so we've spotted a dangerous asteroid heading our way. Now what? Let's talk about potential solutions. Scientists have been brainstorming various strategies to deflect such a threat, and here are some of the most promising ones. First, there's the concept of a gravity tractor. Sounds futuristic, doesn't it? The idea is relatively simple though. A spacecraft would hover near the asteroid, and its gravitational pull would slowly but surely tug the asteroid off its course. This method requires no physical contact, but it does require a lot of time, which may not always be on our side. Next, we have kinetic impactors. This strategy involves sending a spacecraft to collide with the asteroid at high speed. The force of the impact would, in theory, change the asteroid's trajectory enough to avoid a collision with Earth. It's like playing a cosmic game of billiards, but with much higher stakes. And then there's nuclear deflection. Yes, it's exactly what it sounds like. A nuclear device would be detonated near the asteroid, and the resulting force would push it off its course. This is a last resort method though, due to potential fallout and international treaties prohibiting nuclear weapons in space. Now let's look at a real-world example of these strategies in action. NASA's Double Asteroid Redirection Test, or DART mission, is set to test the kinetic impactor method. A spacecraft will be launched to collide with a small moonlet of the asteroid Didymos. The results of this mission will provide invaluable data for future asteroid deflection efforts. While these strategies are promising, they are still in the experimental stage. We're in a race against time to perfect these technologies before we need to use them. It's a complex challenge, but one that scientists worldwide are determined to tackle. Because when it comes to protecting our planet, we can't afford to come in second. As we look towards the future, the question remains, are we ready to defend our planet from a catastrophic asteroid impact? Our future in asteroid defense lies primarily in the realm of ongoing research and development of detection and deflection technologies. Increased understanding of asteroid compositions, trajectories, and behavior is fundamental to this endeavor. Scientists worldwide are developing advanced telescopes and satellite systems to detect these celestial threats earlier and with greater accuracy. Simultaneously, innovative deflection methods are being explored, from kinetic impactors to gravitational tractors, even laser ablation techniques. But technology itself is not enough. The vastness of space and the unpredictable nature of asteroids necessitate a global effort. The United Nations Committee on the Peaceful Uses of Outer Space, or COPUOS, plays a pivotal role in fostering international cooperation in this arena. Comprised of representatives from nearly 100 nations, COPUOS orchestrates collective efforts in asteroid detection, risk assessment, and impact response. Yet the work of COPUOS and the continued development of asteroid defense technology hinge on one crucial factor: funding. Space research and defense are expensive undertakings, requiring significant and sustained investment. Policymakers and the public alike must recognize the importance of funding these initiatives. It's not a question of if an asteroid will impact Earth, but when. Investing in asteroid defense is investing in the future survival of our species. As our understanding of space and asteroids grows, so too must our commitment to defending our planet. The task ahead is monumental, but with the right resources and international cooperation, it is not insurmountable. We have the knowledge, the technology, and the potential to protect our world. In the end, the future of asteroid defense is in our hands. We must rise to the challenge, not just for ourselves but for future generations. For in the grand cosmic dance, asteroids may be the partners we didn't choose, but they're the partners we have. Our survival may depend on our ability to advance these technologies and work together as a global community. So, to sum up our journey through the fascinating world of asteroid defense, we began by exploring the very real threat of an asteroid impact. It's not just the stuff of science fiction. Scientists all around the globe have their eyes to the skies, keeping vigil for any celestial bodies that might be on a collision course with Earth. We've seen how our ability to detect these threats has grown exponentially. From the early days of simple telescopes to the cutting-edge technology of today's space-based observatories, we've come a long way. These advancements, combined with the ever-increasing pool of human knowledge, have made it possible for us to spot potential threats years, sometimes even decades, in advance. But identifying a threat is only half the battle. We also delved into the various strategies that scientists are developing to deflect or destroy these incoming threats. From the brute force approach of a kinetic impactor to the subtler, yet equally as effective gravity tractor, we've peered into a future where we don't just detect asteroids, we actively defend against them. And that brings us to the future of asteroid defense. We've glimpsed into a world where space-based lasers and other high-tech solutions are not just possible but probable. The dedication and innovation of scientists and engineers worldwide are pushing us towards a future where we are not just victims of the cosmos but masters of it. In the face of these monumental challenges, the scientific community is rallying together. The threat of an asteroid impact is a common enemy, one that knows no national borders or political affiliations. It's a unifying force, driving us to work together for the survival of our species. So, while the threat is real and the stakes are high, there's also a sense of optimism. We're not just sitting ducks, waiting for the sky to fall. We're actively working on solutions, developing technologies and strategies that could one day save us all. It's a race against time, but with continued dedication and innovation, we can hopefully be ready to defend our planet from any asteroid threat that comes our way.